Okay, we are going to do a concept map to review Unit 1. So if you can do me a favor, take your journals out. You want to take your journals out, and you do not have to leave a table of contents. I would like you to open to the first page and also try to turn your paper horizontally. So try to do landscape because the concept map is going to be pretty wide, and that way you'll have enough space. Okay, once you get open to that first page, I want you to put the date up at the upper left hand corner. I believe it should be 8/19. Okay, and then we're just going to put Unit 1 concept map. Now, if you're not familiar with a concept map, I like concept maps because it shows us how information connects to each other, okay? And I will try to, move down as I need more space. So long as the connections are there, then we're good to go. Okay, what we have been studying in all of Unit 1 is the term matter. So we're going to go ahead and put matter. Try to spell it correctly. I use circles, but you can use boxes, whatever shape you would like. And the first question we have to ask about matter when we're putting it in categories is can it be separated physically? Meaning I do not have to chemically convert it into something else. I may have to use some specialized techniques, but not necessarily. Okay, I can also keep it, or I can also separate it via physical means just by moving it around. Now, if the answer to that question is yes, then we're going to put it in the mixture category. All right, and we'll define the different types of mixtures here in just a minute. If the answer is no, then we're going to put it into the pure substance category. We'll just put pure. Okay, so remember, with matter, our two big classifications are either mixtures that can be separated physically and pure substances that cannot. I'm going to focus on the mixture side here for just a second so that we can see what we've got going on. Now, with mixtures, mixtures include, there are two types of mixtures that we have. We have what are referred to as heterogeneous. Okay, heterogeneous mixtures, so we want to make that a little bubble. You can always go back and re-watch this video if you need to as well. It'll be on YouTube. It also will be in the learning bundle for Unit 1. So if you need to go back and re-watch this, you can do that if I'm going too fast, because I will check your journals to make sure that this is written down and then it's there sometime in the next week or so. Okay, so mixtures include heterogeneous. They also include what are called homogeneous, or homogeneous, depending on how you're going to say that. And the difference between heterogeneous and homogeneous is that heterogeneous have, scroll down here just a little bit, it's an H there, have. Homogeneous does not have visible parts. Okay, so if you can see the parts and pieces, it's going to be heterogeneous. If you cannot, then it's going to be homogeneous. Now we're also going to get into some examples, some heterogeneous examples include blood, granite, let's see, blood, granite, and there's lots of them, but I think we had chocolate chip cookies. You could have a box of markers like we talked about. Anything that you have visible parts. Okay, so those are all different portions right there for heterogeneous. Now over on homogeneous, let me come back up here. There's also another term for a homogeneous mixture, and that's going to include, or includes, a solution. Anytime you see a solution, that's usually when something is combined with water, and we typically can't see on a molecular level what the structure of those parts and pieces are. Now some things that are solutions are going to include things like air is a homogeneous solution. You can't see it. You also could have salt water, vinegar, anything else where you cannot see the parts and pieces. All right. Okay, so that is going to be our mixture side that can be physically separated, where you have heterogeneous that have visible parts, homogeneous that does not have visible parts. That's going to include a solution. All right, so let's come back up to the top here. We're going to go to the other side of our little brancher, and we're going to have the pure substances. Now, pure substances are going to include an element, or a compound. Okay, and these are the only types from a chemical definition standpoint, right? Because we may have a definition of what pure means that's different from chemistry, but for us, we have pure substances that include elements and compounds. Now, if I start over here on the compound side, compounds include, remember, anything where there are two elemental symbols together. So this may be something like H2O, which is water, carbon dioxide, anything that you have two symbols chemically bonded. And the thing with compounds is that compounds, this is where my concept map's going to get a little ugly. Okay, compounds, come back over here, may be chemically broken down. Okay, not physically. So chemically meaning we're going to have to chemically convert it and change it into a new substance. Broken down into elements. Okay, so we can break those down. Now, for the elements, remember, so if we have water and we add enough electricity to it, we can zap it and separate it into hydrogen and oxygen. Carbon dioxide, same thing. We could eventually, with enough energy, break those chemical bonds and get it separated into carbon and oxygen. Now, elements can include anything on the periodic table, but some common ones are oxygen, nitrogen, and carbon. And like I said, the other thing with elements is that they are organized on the periodic table. And remember, that was the last piece of the unit, Unit 1C, that talked about the different terms related to the periodic table, things like families, things like groups. You need to make sure you know how to label that periodic table that we talked about: metals, nonmetals, metalloids, noble gases, lanthanides, and actinides. But that was the last piece that isn't really a ton on the concept map for this unit, which is the periodic table. Okay, so here is our separation of matter. We've got mixture that includes heterogeneous and homogeneous, pure substances that include elements and compounds. And then the last thing that I do want to mention is how matter is organized or classified. So the last part, somewhere up at the top, it doesn't matter exactly where it is, but I'm going to go ahead and put classified by. And if you remember, the term that we used in order to classify substances is going to be properties. That very first day when we took all the shells and the buttons and the pennies and we separated them, you guys came up with classifications based on things like color, size, shape, texture. In science we do the same thing, we just have a few other formal terms. And those properties that we use typically include intensive or extensive, which is determined on how much material is present. Intensive does not depend on how much is present. Things like boiling point, melting point, so those bigger breaks. And then also extensive, which does depend on how much is present. Things like mass, volume, length, etc., etc. And then you also have physical and chemical properties. Physical and chemical properties. And we talked about this, where physical does not change it into something new. any of those changes of state, which is not on here anywhere, things like melting, freezing, evaporation, vaporization, sublimation, deposition, any of those are going to be physical changes. Chemical properties will be anything that does change it into something different. And if you remember, there were 4 indications that a chemical reaction took place. You had your bubbles, your color change, your precipitate, as well as, nope, I want to keep the same color here, and bubbles, precipitate, color change, and energy release is heat or light. Now, the only other thing that I do want to mention, or that we talked about and that we mentioned here, are some of those physical separation techniques. So when we talk about being separated physically, I'm going to try to see if I can squeeze these in here. We did some of these in practice in class, but some of those physical separation techniques are going to include things like vaporization, where we simply let the water evaporate. We can speed that up by heating it. We also had decanting, where we try to speed up separating a solid from a liquid by pouring off some of the liquid first. We did that with the pennies. Ooh, let me see if I can get all this squeezed in. Vaporization, decanting, filtration, where we set up the filter papers and did it that way. And then we also are going to have, sorry, I said concept maps can get ugly, our centrifuge, where you spin something really fast and the density separate it. And then last but not least, where can I try to fit that in? I'll just put right here. I'm going to put paper, and I'll put a C for paper chromatography. Okay, we saw that with the little ink dot the other day. When the water ran up it separated the different inks based on the fact that they had different masses. Okay, so those are some of our physical separation techniques. So though it's a little messy, it kind of shows you how all the information in Unit 1 is connected. Remember, you have that test prep planning sheet to kind of help you organize yourself, but hopefully this helped you review Unit 1 just a little bit. If you have any questions, come ask, and we will still be prepared for our test. Okay, thanks a lot.